Hi, this is Nick Shar with Radwave, and today I want to take a second to talk not just about how Radwave does distributed processing, but how it actually enables decentralized processing and decentralized analysis, and kind of what that all means for the Breakthrough Listen project. So let's dive into it. So as we saw before, with Radwave, we can allow multiple users to all send requests to the Breakthrough Listen uh, machines at a reasonable rate controlled by Radwave so we don't um, oversaturate this system, right? So, but this way we can get these individual files downloaded and sent to users at a reasonable concurrent rate. But what happens when we have users? Let's say that we have two users and they're interested in the exact same data, right? So they're both sending these requests to the Breakthrough Listen system. They would both be asking for the exact same data and potentially doing the exact same processing. In this situation, we're doing a few things redundantly, right? So we're uh, requesting the exact same data to be downloaded, which further stresses this bottleneck. We're doing redundant processing on this side as well between these two machines, which just makes it pretty inefficient overall. And so one of the interesting things about how Radwave functions is with the processing that the engine does and the way that the Explorer operates. It allows rendering not just of the data that's been processed locally, but users can directly talk to one another. So the Radwave engine here that processes data, if the user enables serving that data out to other users, then the Radwave Explorer on this side can connect directly to their machine and view the results without having to process it themselves. And this is something that the Radwave public servers actually do. So here with Radwave, we have a cloud instance that's serving out a small amount of data. So that way everyone can kind of get started without needing to do this bulk processing up front. They can have something they can view immediately. But any of the other users can do the exact same thing. And what this enables is a setup that looks much more like this, where each of our users can have a set of results that they're able to share with the rest of the people in the system. So this saves us a, a significant amount of storage that each individual user has to have on their system. It saves computation, so we're not having to do redundant, like heavy processing on each of these machines. It saves power. It's just more efficient since we have a smaller number of users doing that distinct processing, and it saves us time ultimately because this is a time burdensome amount of processing. And we can even have users who really don't necessarily have the ability to store a lot of data on their systems, that can just purely be clients and provide value simply by looking at the data. And that can be their way to really assist this project. Because ultimately, you can have these two separate groups, one that's really good at managing and maintaining these small clusters of variable size, and then we can have kind of passionate users who really just want to look at the data and peer into it. So I myself am one who really enjoys the heavy processing part of it, the analysis. It's cool. I do enjoy it, but the processing for me is the more interesting part. But there's a lot of people out there who, are really curious about what signals actually exist, and particularly with uh, study related efforts in general. There's just a large public interest in this data, in the information, and that really brings in some interesting points here with, how many people could we actually have processing this data? There's 2 petabytes of it, so it's too much for any one normal user to be able to serve on their own and look through on their own. Um, but as a community, we may be able to make some significant headway. So just to kind of highlight that, let's look at the actual numbers. So here on Wikipedia, we can see some information about the Study at Home project. And in particular, let's look at the statistics. So they had over 5.2 million participants worldwide, with over 145,000 active computers in the system, um, from 233 countries. This is way back a decade ago, back in June 2013. So there's just a phenomenally large number of users. So if we take our, 2 petabytes of data and divide it amongst 145,000 active machines, what does that give us? Something in the order of, you know, uh, several gigabytes required of each individual user, which isn't that bad, right? So you could potentially have the entire breakthrough listen data set be hosted by a decentralized set of users, um, being viewed by enough people to actually get eyeballs on virtually all of that content, um, which is just a phenomenal thing. There's no real detector, especially for signals that we don't know how to characterize well, um, that you can do algorithmically. So as someone who designs algorithms, it's very, very difficult to design an algorithm for a signal you've never seen before. Um, to understand what exactly you're detecting is a challenge. But as a human with eyes and with a brain and an ability to perceive abnormalities in a very natural and organic way, um, you it's a real tough system to build. But we all have it just innately. And so if we can enable, a large number of people, of humans, who can use their, exquisite senses to look at this data in detail, and think of different ways of processing it, then we could find some interesting things in it, whether it's SETI or radio astronomy, or radio astronomy related phenomena, um, just kind of building an understanding of our universe. It's super exciting. So let's see how exactly we do this with the Radwave Explorer. So here on my machine, I've got a Docker container running, so I can show a system with a different IP address. But within this Radwave folder, there's a Radwave engine directory. And so if we go into there, we can see inside of here, we have a downloads directory. So this is where all the raw Guppy files are downloaded into through the Radwave engine. We have a prep directory, which holds some intermediate files, since you can't fit everything inside memory. And then we have a public directory where we have, the final files that have all the data that you actually look through with the Radwave Explorer. So go into that one here. We can see that we've got a number of files present. And in this particular case, there are 2 different collections that we did here. And if we just start just a simple HTTP server, so just a simple, I'll put this up, you see what it says. So it's a simple static file server that's running. That's all we need to do to connect. So now let's open up our Radwave Explorer. And from here, you can see at the top, this is a list of backends. So I have a data directory. That's actually what the Docker container is hosting right now. But we'll connect to it differently. So this is just locally on my machine. We have the default directory, which is where Radwave engine will place files by default. And then we have the Radwave public backend, which is hosted in the cloud. But if we click this plus button right here, we can select another backend to connect to. And the HTTP one would be some remote system. And so here, all we have to do is enter in the IP address and the port, which, let's see what the port was, 8081. And then we automatically connect to it. So here we can see we're kind of accruing a list of backends that we can connect to, and this should scale up fairly well. And now we can click on each of these individual ones, and we're accessing it not directly from our machine, but we're accessing another machine remotely on the system. And so just like we can zoom and pan around locally with a machine that we're connected to, and we can listen to signals that exist here and whatnot, we can do the exact same thing over the network. And so, yeah, it's really how simple it is. It's just a simple static file server. Now, I will say at this time for alpha testers, there's no support for security at this point in time. So I'm highly recommending you to only connect to servers hosted by people that you know. So just friends, whoever, people that you know. I wouldn't connect to other systems since there's no security at this time. I have some friends who are really good with network security, and I'll be reaching out to them before I finalize the implementation. So that way we have security built into the entire chain. And that'll be available once the general release is all the way there. So I'm still working on that, but I'm confident it'll be worked out relatively shortly. So, yeah. So go ahead, have a great time with your friends, test out that feature and see if it works. And then be rest assured that in the future, we should be able to have it secure so you can connect to other uses as well that you're not so knowledgeable about. So that's all I have at this time. Remember that there's still an open call for alpha testers available. So we've had people slowly rolling in. I'm super excited to get more and more of you up there. There's really no cap on how many alpha testers we can have. So all you have to do is subscribe to the blog. So here's the blog post. We have tutorials that are available for both the engine and the Explorer. We have the alpha releases. As quickly as I can, rolling out these fixes that the alpha testers have pointed out need improvement. And there's a Discord channel. So any of you who want to chat, have questions, feature requests, I love constructive criticism. So any sort of bugs, features, things that seem weird, things that aren't written quite right. If you don't understand some of the controls and would like better information provided about that, simply let me know and I'll be happy to add all that in. So thank you so much, and I'll talk to you soon. Bye.